Hello, and welcome to the United for Math series on line plots. In this lesson, we will be problem solving using line plots. It's important that students have strong knowledge on how to add and subtract fractions before we go into problem solving using line plots. It's also important that students know how to create a line plot and interpret data on a line plot. If students are still struggling with that, check out the first lesson in this series titled Creating Line Plots. Let's take a look at our first problem. So here we have a line plot that's already been created for us. This line plot shows the table lengths in yards. So I always tell students, if there are missing values here on the number line, go ahead and fill those in. It'll help you later. So we know that between 1 and 2 will be 1½ and between 1 and 1½ is 1 1/4. Between 1 and 1/2, between 1½ and 2 is 1 3/4. Moving over here, between 2 and 3, we have 2 1/2. Between 2 and 2 1/2 is 2 1/4. And between 2 1/2 and 3 is 2 3/4. So now we have our missing numbers filled in. We can look to see what our problem is asking us. What is the difference between the longest table length and the shortest table length? So it's important to understand that we have a table with a length of 3 yards here. Students may want to immediately jump to 1 because it's the smallest number on the number line, but there are no tables represented by 1 yard. So we have to go where the X's are, where we know that there are tables representing that certain length. So we have our longest table is 3 yards and our shortest table is 1 1/4. So here we will be subtracting our longest table, which is 3 yards, minus our shortest table, which is 1 1/4 yards. So let's go ahead and set this up vertically. So we have 3 minus 1 1/4. Well, I don't have anything here to take 1/4 from, so I'm going to make this fraction 3. We're going to borrow a whole as a fractional unit from that. So I'm going to make that 3 a 2 and my fractional unit 4/4 as my 1 whole, so I can easily subtract 1/4 from 4/4. So 4/4 minus 1/4 is 3/4, and 2 minus 1 is 1. So the difference between my longest table and my shortest table is 1 3/4 yards. So we can use this line plot to help us solve this problem. So remember, when we're faced with a line plot, we're only focusing on the data that has X's above it. So let's take a look at another problem-solving question. So here we have the same line plot, and I went ahead and filled in those missing numbers again for us. Here's this question says, what is the total length in yards of all the tables? So now, again, students don't want to focus on these numbers that don't have any tables represented. But we want the total, so we will need to add up all the tables for all the numbers that are represented here. So I have one table that's 1 1/4 yards long, and I have another table that's 1 1/4 yards long. So I'm going to need to add that twice. So I have 1 1/4 plus 1 1/4. I don't have any tables that are 1 1/2 yards long. So let's look at the next one. I have one table that is 1 3/4 yards long. Then I have my 2 yards. I have 1, 2, 3 tables that are 2 yards long. So 2 plus 2 plus 2 plus 2. Then I have 2 1/4, one table that is 2 1/4 yard long, one table that is 2 1/2 yards long, and then my final table that is 3 yards long. So now we need to add up all of these numbers. I tell students to add up our whole numbers first because they're really easy to add together. So 1 plus 1 plus 1 is 3. Then I have 2, 4, 6, 8, 10, plus 3. So once I've added up all my whole numbers, I know that 3 plus 10 is 13, plus 3 is 16. So now let's look at our fractions. Are there any compatible fractions that we can add together that will make one whole? Well, I see that 1/4 and 3/4 is a whole, so I'm going to add 16 plus 1. Ooh, then I have 1/4 plus 1/4 plus a half. I know that 1/4 plus 1/4 is 2/4, which is the same thing as a half. And a half plus a half is another whole. So I have 16 plus 1 is 18. So the total length in yards of all the tables is 18 yards. So remember, if a problem asks you to find a total of something on a line plot, students need to remember to only focus on those numbers that have X's above them on the line plot. Then go ahead and write out each number, and I always say, you might as well add up the whole numbers first because they're easier, and then look for compatible fractions that might make a next whole number. Let's take a look at one final problem-solving problem. All right, here's our same line plot again. Here's the question. If we redistribute the table lengths so that all tables are the same length, how long will each table be? That word redistribute can really trick up kids, but the word redistribute really means that you're actually finding the average or the mean of the entire line plot. So let's take a look at how students would need to solve this. So here, when we start to redistribute, we're going to add up all of our table lengths, which we did in our first problem. So we know that the total length of all the tables is 18 yards. Well, now we want to redistribute this evenly so that all the table lengths are the same length. So I'm going to take this 18 and I need to figure out, how many tables am I working with here? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take my total 18 yards and I'm dividing that up by my 9 tables so that each table will now be the same size. Well, I know that 18 divided by 9 is 2. So if I were to redistribute this line plot, I would put all 9 X's above my 2 to show that every table will need to be 2 yards long in order for them all to be the same length. Solving problems using line plots can be really fun. We just have to figure out what the problem's asking us and go step by step. Remember, when problem solving using line plots, we only want to focus on those numbers that have the X's above those numbers. And when we see that word redistribute, it means that we're finding the average or the mean so that whatever's on that line plot will be equally shared or equally broken up. We look forward to seeing you in our next series where we will be working with fractions as they relate to division. Thank you so much for joining us. We'll see you next time.